Hey everyone, Mike here. In my last video, I received my first satellite signal. In this video, we're going to go back and look at how you predict satellite passes over your area so you know where to point your antenna to receive your signal. We're also going to look at the signal we received from the XW1 or HOPE-1 satellite so that we can decode the telemetry and get an idea of what that satellite is sending in its beacon. In that first video, I was just trying to receive a signal from any satellite, but we'll go now to the computer and I'll show you how to look for specific satellite passes or just look for any satellites that are passing over your area. All right, so there's a few different sites I've been using to track satellites. This one, N2YO, I'm showing here. This is the overview page for the satellite itself, the one that I had on my previous video, the one that we received the signal from. And what you see is lots of details about this satellite's orbital parameters. As well over here, you can see a real-time position. Right now it's just over Europe. And the reason I like this site is for amateur radio satellites, it includes details on the various signals or modes that the satellite supports. So you can see that this satellite actually has 3 different signals, and it tracks that these first 2 are inactive. Those components of the satellite have been disabled. But this third one, and this is the one that I received in my previous videos, you can see is the beacon, and it gives you the frequency. The mode, CW, is Morse code or carrier wave, the call sign that it will be using, and its status. So right now it's active. So that's great to see where it is currently. Another key aspect of the software is the ability to predict future passes. So I'm going to look at the next tab here. This is the 10-day predictions. And the nice thing here is it's showing the 10-day predictions for when the satellite will pass over my location. So you can see here each line in this list is a point where this satellite will cross over my horizon and I will be able to see it line of sight from where I am on the planet. You can look at the pass to see where the satellite is passing. So you can see I'm here in Nova Scotia, and the satellite is going roughly over Maine in the United States and then to Quebec. So it's at this point, 5:52, that's where it's going to be the closest to me. And you can see I point it over in this direction to the horizon, and that's where I'll get my strongest signal. And then once you actually have chosen your pass and you're out with your antenna trying to get the signal, then the live tracking can come into play where you can actually see the satellite as it approaches. Right now it's nowhere near me over in Nova Scotia. But as it does come over, you can see the real-time data so that you can see exactly the main things you're interested in is which direction it is and which elevation it is. Those 2 numbers tell you where to point your antenna. And its position as it approaches you, that's what we'll use to find out its relative speed so that we can calculate the Doppler offset. So those 3 views give you your predictions of passes and real-time data over where it's coming. Celestrak, they have the permission from NORAD to distribute these 2-line element sets. So if you actually look at the amateur radio satellites, you can see they've got those 2-line elements for every satellite that they know about. And if I just search for HOPE-1, there's the 2-line elements for that satellite that I was talking to, or that was talking to me. They also have that same data for the Starlink satellites. This is what we'll be using when we write our custom software. So you can see for every one of the Starlink satellites, it has those same orbital parameters to know exactly where it is. And of course, there's many more Starlinks than there are amateur radio satellites. The last thing I wanted to show Celestrac has a neat 3D visualization. And what you're looking at here is that same satellite, Hope 1, and you can actually see where it is in real time on this 3D globe. So I thought that was pretty cool. So this just gives you an idea of all of the various tools to track satellites and predict where they'll be. I'll be using this same data, the same technique, to write my custom software to predict the location of the satellites that I'm interested in. All right, now looking at the actual beacon signal we received from the XW1 or Hope 1 satellite, I didn't get a great signal because my radio was in FM mode. The handheld radio only supports FM, not CW modulation. So just listening to the signal, it's really hard to figure out because the silence is where normally you would hear the tone if you had a proper CW receiver. But what I was able to do is actually just looking at the editor footage. You can see here we've got the sound levels, and you can actually see the silence and see the dots and dashes. So when that plays, you can hear the Morse code. So what I did is I actually just went through my recording and translated all these dots and dashes on the waveform into actual dots and dashes here, and then translated the Morse code. And what I got is this signal here, BJ1SA, XWXW, and then a series of groups of 3 letters, numbers. These are the telemetry signals, all the way down, and then XWXW again. And if you look it up, the satellite, they've actually published a data sheet on the telemetry coming from the beacon. So you can see the telemetry frame is about 40 seconds of data, that's what we received, 10 seconds of silence, and then it just repeats 40 seconds of data. It tells you the speed, 15 words per, they probably mean words per minute. And then this is the kind of translation table. Those letters that we see, you can see T, that maps to 0. So that's why it's kind of a mix of letters and numbers. They actually just map across to numbers. So what I did is I took my signal with the letters, and I'll go up to the top here. I wrote it out, and then the line below, I wrote the number equivalent. So just using that lookup table, T becomes 0, A becomes 1, U becomes 2, and you get this number net, or this signal here. And these little groups of 3 numbers correspond to the telemetry. So if we go back to our data sheet, scroll down, they have the details of the telemetry. You can see there's my call sign, XWXW, and then the 13 channels in order. And then the next page actually goes into the detail of each one of these channels and describes exactly what it is. So you can see this first one, channel 1, is either going to be all zeros for the transponder working and the beacon, or it's going to be all ones for only the beacon working. And if we go back to the data, we can see that this first channel, channel 1, is all ones. So that means it's only transmitting on the beacon, not the transponder. The next group is all zeros. So going back here, we can see channel 2, transponder working status. All zeros means only the beacon is working. The next one, transponder temperature. If it starts with a 1, that means it's a positive number. If it starts with a 0, that means it's a negative number. So we should expect 1 something something. And if we look over here, we have 128. So that means positive 28 degrees Celsius. The next number is 145. Going down here, we can see beacon RF output power, so 145 milliwatts. And each channel you can decode using this table. So sometimes you divide by 100, Sometimes you multiply by 3. But that's all the different values. And you can see most of these ones down here corresponding with the transponder and this digital store forward. All of those have been disabled on the satellite, which is why most of these are all zeros. But it's just neat. This CW signal tells you all about the satellite's operating mode. If I'm lucky in the future, there'll be a similar beacon concept with the Starlink satellites. But given that they're not designed to be received by the public, I'm guessing it won't be nearly as easy to decode as this signal here. So I hope you're finding this interesting. If so, subscribe down below, get notifications of my new videos. Next in this series, we're going to be writing custom software to track satellites and actually tune the radio to receive the signal that we're looking to receive. See you next time.